Hello, my name is Androutsopoulou and I will present a research which is done together with Anagnostopoulos. This research introduces a novel methodology based on the research of urban public spaces as network configurations. Real-time traffic data are taken into account in order to determine and categorize the network's connections. We focus on dynamic network connections. So 10 public spaces of Zographos municipality in Attica in Greece are selected and the connections between them will be determined and categorized through real-time traffic data. Car, bus, and pedestrian traffic data form dynamic datasets corresponding to trip durations. The initial network configuration is formed through the mutual connection of every pair of public spaces. All 10 public spaces are initially interconnected using bidirectional connections of equal strength, that is, connection weight, and each one of them is pointing to a node. This appears to be a symmetric graph, since all nodes are equally interconnected. Three means of transport produce respective variables per network connections at every instance, which correspond to trip durations. In order to construct a dynamic network whose connections will alter in strength according to real-time traffic data, car, bus, and pedestrian trip durations from each node to every other node of the network are collected. The time needed to reach node B from node A is not necessarily the same as the time needed to reach node A starting from node B, as the proposed routes and the respective distances covered may differ. The collection of real-time traffic data is made possible through the use of datasets retrieved from Google Maps for the three means of transport. Trip durations from any given node to any other node are collected for a total time of 12 hours, starting from 8:45 to 8:15, and for a total of 24 steps using 30 minutes intervals between them. This produces 24 datasets, 100 time values in seconds, and for three means of transport, that is 7,200 values, which show real-time travel data. So in order to be able to categorize the network's connections and produce variations of the network structure, which will correspond to real-time traffic data, clusters of the connections between pairs of public spaces are produced using k-means clustering algorithm. Being able to collect real-time travel data from the actual urban environment, a series of clustering results is produced. These 24 clustering results correspond to 24 different groupings of network connections. The translation of real-time traffic data into network connections is made possible through an interpretation of cluster results into connections weight. A specific weight value is assigned on connections belonging to the same cluster. Shorter trip durations are translated into stronger directed connections between network nodes, while longer trip durations are translated into weaker network connections. This way, different network configurations are constructed for every instance. Connection strength values alter continuously following the alterations of the actual urban connections groupings. Since the time needed to travel from node A to node B is not necessarily equal to the time needed to travel from node B to node A, all 10 public spaces are interconnected using pairs of bidirectional connections which differ in weight. Different network configurations are constructed for every instance. Connection strength values alter continuously, following the alterations of the actual urban connections groupings. The use of real-time data reveals in real conditions the self-adapting behavior of the network of urban public spaces. The transitional qualities of the urban environment produce simultaneous but not analogous changes at the network structure. Thank you.